Hello, my dear students. How you all are doing? Welcome to the Unacademy YouTube session number 3. Welcome, my dear students. Very good afternoon to each one of my dear students. Hope you all are doing great, fabulously fine. Good afternoon, Ananya. Very good afternoon. So, good afternoon. Very good afternoon, Pooja. Today being third session on fluid dynamics. Okay, today's session I'll be focusing on the conceptual understanding and some problems we'll just try to take a look. Okay, so now to begin with, I'd like you to invite each one of you once again on this Unacademy YouTube live platform. Welcome to this particular session, and I wish each one a very good afternoon. And on the basis of our recent classes, recent sessions, I am very much energized by the performance of the students who are actively participating in this particular YouTube session. Very good afternoon, Uday. Very good afternoon. Now, let's make a progress into the part of our discussion. So, as we all know, my name is Uttam Kumar Umarji. I'm an MTech graduate. I'm your personal physics teacher on Unacademy platform, and in fact, this is my 19th year that I'm spending, and I'm presently at rank number 2 in Karnataka CET segment. I wish Deepa a very good afternoon. Deepa, very good afternoon. Now, with reference to the sessions that are being conducted by Unacademy on YouTube Live, obviously these sessions are those which will give you further acceleration into various competitive examination preparation. Okay, and this particular session is specifically connected to Karnataka CET 2021. Okay, and my dear friends, presently I am working as a NEET JEE faculty at Prarthana PU Science College in Bagalkot, and here on Unacademy, this is my third month, which is in progress, and I'm going ahead with great guns because of my dear students. Okay, so I'm always for the students, and Unacademy is also always for the students. Now, what exactly we can offer you on Unacademy? Now, I would like to introduce you to Unacademy Plus subscription. Now, Unacademy Plus subscription, it has got various offers for each one of the students over here. So, firstly, for Karnataka CET 2021 aspirants, we have these plans which I have listed them down. So, we have a 12-month plan, okay, and this 12-month plan would cost you rupee 12,375. Okay, and we have a 6-month plan which will cost at 10,125 rupees. Okay, and 12-month plan per month cost, average monthly cost would be 1031 rupee per month. And 6 months plan, it would cost you around 1700 per month. Okay, and then we have one trial plan, which is 1 month plan. This is only for new subscribers, which would cost you 2250 rupees. Okay, and this is, as I was mentioning, this is a trial plan, my dear students. Yeah, Janvi, very good afternoon, Janvi. Very good afternoon. So here, as we progress, what we get out of these uh, plus subscription plans. So here, as we all can see here, we are getting a premium content at affordable price, structured live courses with doubt clarification sessions which are live. Okay, then quizzes are conducted at a regular interval for your self analysis, my dear students, and batches for complete preparation. So this is key highlight for you. And then test series for DPPs, full length mocks, etc. are conducted with analysis. This is also a prima facie offer plus subscription. So all in all, I would like to say a single subscription for unlimited access. Okay, and there is presently an ongoing comprehensive live batch. Okay, so you all can think about it and go ahead and join. And when you are joining to Unacademy Plus subscription, use the referral code UTTAMLIVE to avail a 10% discount. So a 10% discount would be awarded to you on any one of these plans which I have mentioned here. Okay, so that is the advantage and that is the plus factor from your Unacademy faculty. Okay, so this is my personal code. You can make use of this referral code and get good benefits out of it. Okay, thank you for being patient in listening to all these descriptions. I hope you all are pretty much energized now. Now let's move ahead with our main part of discussion quickly. So when we talk about energy of flowing fluid, now let me begin with this particular concept here. Energy of flowing fluid, we have three kinds of energies. First one, it is pressure energy. Okay. Second one, it is kinetic energy, and third one, it is called as potential energy. Okay, amongst them, pressure energy is the energy possessed by a liquid by virtue of its pressure. Okay, so hence it is directly the measure of work done in pushing the liquid against pressure without imparting any velocity to it. So we should understand it in this way. Okay, now secondly, we have pressure energy is denoted by pressure multiplied by volume. Okay, so this pressure multiplied by volume, this concept comes by your P inversely proportional to V. So this is according to which law, my dear students? This is according to Boyle's law. Okay, fine. Next, pressure energy per unit mass of the liquid can be very easily written as pressure divided by density, because we know that if I write PV divided by mass, then it is V by M. V by M is 1 by density. So from that we will obtain this particular pressure energy per unit mass of the liquid. And pressure energy per unit volume of the liquid is P. Okay. Then talking about second form of energy, that is potential energy, my dear students. It is the energy possessed by liquid by virtue of its height or position above the surface of earth or any reference level taken as zero level. Okay, so with reference to zero level, it is by the virtue of its height or position, my dear students. Okay, so hence we can say that potential energy of liquid is written as mass into acceleration due to gravity into height. Okay, so thus we can also mention potential energy per unit mass of the liquid as G into H, because mgh divided by m will give you G into H here. Then potential energy per unit volume, if I would like to mention, then mgh divided by volume if I make, then m by v is obviously density rho here. So that is what we are having here, my dear students. Now let us take a look at third form of energy, that is kinetic energy. Now kinetic energy, it is the energy possessed by the liquid by the virtue of its motion or velocity. Okay, so obviously kinetic energy is given by half m into v square. Then remember, kinetic energy per unit mass is half v square, and kinetic energy per unit volume is half into rho v square, where rho is what? Density of the liquid, and mass by volume is density. So that is why we can write half mv square upon volume as half rho into v square. Okay, so these are various types of energies that are there in case of a flowing fluid. Right. Next, we should talk about Bernoulis theorem quickly. Now, according to Bernoulis theorem, the total energy, that is pressure energy, potential energy, and kinetic energy per unit volume or mass of an incompressible non-viscous fluid in steady flow through a pipe always remains constant throughout the flow, if or provided there is no source or sink of the fluid along the length of the pipe. Okay, so this statement itself indicates that total energy remains constant, implies it is talking about total energy constant in the sense conservation of energy, my dear friends. Okay, so hence mathematically we can write for per unit volume as P plus rho gh plus half rho v square is equal to constant, because I have already mentioned to you what each of these energies are per with respect to volume. So that I am mentioning here. So obviously this is Bernoulis theorem for per unit volume. Similarly, Bernoulis theorem for unit mass of liquid flowing through a pipe can be written like this as P by rho plus GH plus half V square is equal to constant. Okay. Now, let us take a look at some interesting questions on Bernoulis principle and continuity equation. Okay. So accordingly, the question is, in which one of the following cases will the liquid flow in a pipe be most streamlined? Okay, so this is the question that we have. So now, in order to answer to this question, my dear students, we can consider this. For streamlined flow, Reynolds number is found to be proportionate to what? R into rho divided by eta. So this is Reynolds number. Okay, and for streamlined flow to happen, Reynolds number should be less, because in my previous session I told you regarding that. If you have not watched that video, kindly go through that video and you would get to know what is Reynolds number and what are its various values. Okay, so accordingly, Reynolds number proportionate to R rho by eta must be less. So that means we can say that for less value of Reynolds number, radius should be more and density should be less. I'm sorry. So for less value of Reynolds number, we should see that Reynolds number is directly proportional to radius and it is directly proportional to density. So accordingly, we can say that if density and radius are less, Reynolds number will be less, right? Then coefficient of viscosity, since it is inversely varying with Reynolds number, so hence I can say coefficient of viscosity must be high. So under this pretext, we can comfortably see that our option over here is what? Liquid of low viscosity and liquid of high viscosity and low density flowing through a pipe of small radius. So that is option B here, my dear students. So that we have picked here. Then second question quickly. Now, two water pipes of diameters 2 cm and 4 cm are connected with the main supply line. The velocity of flow of water in the pipe of 2 cm diameter is. So these are four options that they have mentioned here. Okay. So clearly, velocity of flow of water in pipe of 2 cm diameter they are asking. So here I would like to utilize continuity principle here. Okay. And in order to use continuity principle, what I will do, diameter dA is 2 cm, therefore RA will be what, radius will be 1 cm, and dB diameter is 4 cm, therefore RB is 2 cm. So hence from continuity equation I know that area into velocity is constant, so therefore I can say VA by VB is equal to AB by AA. Okay, so that is nothing but pi into RB square divided by pi into RA square. So thus I can write this as 2 divided by 1, that will become whole square, that will become 4 here, my dear students. Okay, so VA is equal to 4 times of VB. I think this was option A here. Okay, now moving on to question number 3 here quickly. Now in third question, the problem is like this. An incompressible liquid flows through a horizontal tube as shown in the following figure. Then the velocity v of the fluid is. Okay. So to solve this particular question, what we shall do is, now these are the four options that have been given to us. Please make a note of them. So 3, 1.5, 1, 2.25. Okay. So let's progress with the solution. So you can say, if the liquid is incompressible, my dear students, then mass of liquid entering through the left end should be equal to mass of liquid coming out from the right end. So this is exactly according to law of continuity, right? So hence I can say mass that is entering, that I am taking it as capital M, mass that is leaving is m1 plus m2, right? So hence I'll apply continuity equation, that is A into V1 is equal to A into V2 plus 1.5 A into V, right? So over here V is unknown, that is what we are supposed to find here. So accordingly, if I substitute A is equal to 3, A is equal to A as it is if I put, and V1 I am taking it as 3 and V2 I am taking it as 1.5, then I can very easily take out A as common on right hand side, and thus I can cancel it off all across. So hence I tend to see that I'll get 3 minus 1.5, 3 minus 1.5, that is 1.5. Therefore V is equal to, I'll get this as 1 meter per second, my dear friends. So 1 meter per second is the answer that we have. Okay, so now let's progress to question number 4 quickly. Water enters through end A with speed v1 and leaves through end B with speed v2 of a cylindrical tube AB. The tube is always completely filled with water. In case 1, tube is horizontal, and in case 2, it is vertical with end A upwards, and in case 3, it is vertical with end B upwards. We have V1 equal to V2 for. Okay. Now this is the typical variety of question that we have. Okay. Now we can say that this can happen with accordance to continuity equation, and this equation was derived on the principle of conservation of mass, and hence it is true in every case. Either tube remains horizontal or vertical. So obviously our answer should be, in all cases we will have the same scenario. Okay, so that is what I have to say with reference to the solution to this question. Okay, so I hope it is clear. Now let's progress to question number 5 quickly. Water is moving with a speed of 5.18 into 5.18 meter per second through a pipe with a cross-sectional area of 4.2 centimeters square. The water gradually descends 9.66 meter as the pipe increases in area to 7.6 centimeters square. The speed of flow at the lower level is, okay, and first option is 3 meter per second, second option is 5.7 meter per second, and third option is 3.82 meter per second, and fourth option is 2.86 meter per second. Okay. Now, I'll make use of firstly continuity equation here. So over here, according to this, A1 V1 is equal to A2 V2. That is what we have. Then I see that I'll get this as A1 is 4.2 into V1 is 5.18. That is equal to 7.6 into V2. Okay, so V2 is unknown, so that is what we can find it as 2.86 meter per second, because that would be 4.2 into 5.18 divided by 7.6. Okay, so 2.86 meter per second. So it is option D here, right? Okay, now let's progress to sixth question, my dear students. The velocity of kerosene oil on a horizontal pipe is 5 meter per second. If G is equal to 10 meter per second square, then the velocity head of oil will be, okay. Now velocity head is v square by 2g. So that is what they are asking, and options are 1.25, 12.5, and 0.125 and 125. Now these are four options for us. Fine. So now velocity head is v square divided by 2g. So which is obviously 5 square divided by 2 into 10. That is acceleration due to gravity. I am taking it as 10 here. So therefore 25 by 20, that should give me 1.25. Right? Yes, yes, absolutely. In fact, it's correct, my dear students. So I hope it is correct. 1.25 meter is which option, my dear students, here? So it happens to be option A here, right? Okay, you all are answering correctly, my dear students. Okay, so options, you are helping me out. Thank you very much. Yes, PYQ. Yes, okay. Sureka, I could not understand your term. PYQ means what? Is it thank you? Okay. Okay, okay. So you need to know like how to read physics, because it's difficult self-reading. Okay. So if you are preparing for entrance exams, Sureka, then my suggestion, you just be thorough with the concepts first. Okay. So in becoming thorough with the concept, self-reading is necessary, but prior to that, some particular guidance is required. A teacher's guidance is a must, because you cannot say that I know this concept, that's why I'm 100% sure that I will clear the entrance. But my suggestion, you take a small amount of guidance from your teacher and make a self study. That will definitely boost you up, and I will definitely help you out if you please attend my special class sessions also on an academy platform. Then it will help you out a lot, Sureka. Okay, so I hope I have answered to your queries. So a better thing would be like previous year questions. Those things come only when you are perfect with concepts. Theoretical concepts are must. So please be under this pretext, okay, and try and attend my special class sessions also on Unacademy. Okay, you can find me as Uttam Kumar Umarji, okay, on Unacademy, and my code is Uttam 2021, and my live code is Uttam Live. So you please follow me, then you will definitely get a good help out of it. Okay, this is my promise, this is a teacher's promise. Okay, Sureka, thank you. Fine, now let's progress to seventh question now. In the following figure is shown the flow of liquid through a horizontal pipe. Three tubes A, B and C are connected to the pipe. The radii of tubes A, B and C at the junction are respectively 2 centimeter, 1 centimeter and 2 centimeter. It can be said that, okay, now they are saying that option A, height of liquid in the tube A is maximum. B, height of liquid in the tube A and B is the same. Height of liquid in all the three tubes is the same, and height of liquid in the tubes A and C is the same. Now, over here, remember that the diameters of a tube A and C are same here. So this is one thing that we should remember. So hence we can say cross section area of A and C will be same. So due to that reason, we can say velocity of liquid through A should be equal to through C. So therefore, we can say that option D is our right choice. Yes, Deepa, very good. Very good, Deepa. So therefore, according to Benoullis theorem, pressure at A should be equal to pressure at B. So therefore, we can say height of liquid is same in both the tubes A and C. Right? Very good, Deepa. Okay, now let's progress to question number 8. Now, a manometer connected to a closed tap reads 3.5 into 10 raised to 5 Newton per meter square. When the valve is opened, the reading of manometer falls to 3 into 10 raised to 5 Newton per meter square. Then velocity of flow of water is. Very easy question, right? So now here we have this particular scenario. Quickly I'll just wind up and finish this question because the time is up, my dear students. Now I'll apply Bernouilli's theorem for unit mass of the liquid. So accordingly, P by rho plus half rho v square should be equal to constant, because as we should remember, potential energy is 0 here. Okay, so thus as the liquid starts flowing, okay, Surekha, if you're not there on Unacademy app, my request, you install the app, okay, and register, and please do start visiting the sessions over there. This is my kind request. Do it as soon as possible. Today evening at 5 p.m. I have a session. You can attend that, okay, and that session is based on system of particles. So you please make sure that you'll attend that. Okay, so this is my stern request. Okay, fine. So now as liquid starts flowing, its pressure energy becomes small, because velocity, when it increases, pressure decreases. So thus we can say half v square is equal to p1 p minus p2 divided by rho, right? So accordingly I can say half v square is equal to 3.5 minus 3 whole power 10 raised to 5 multiplied by divided by 10 raised to 3. So accordingly I'll get this as 2 into 0.5 into 10 raised to 5 divided by 10 raised to 3, and over here I can very easily cancel out 10 raised to 3, and we are left with 10 raised to 2 into 2 into 0.5. So I should get v square is equal to 100. Therefore, I'll get v is equal to 10 meter per second. Okay. So this is the question, last question for the day, my dear students. Now the time is up. We are given half an hour time. So obviously this half an hour time is over. So I suggest you all to attend my next Unacademy YouTube live session on 24th of this month. Okay, so until then, I'll see you guys once again back after 3 more days. Okay, thank you very much. Have a fantastic, fabulous time ahead. Have a nice evening. Bye bye. See you. Thank you, Janvi. Thank you, Uday. Have a nice time, fabulous time. See you then. I'll see you in my next session. Okay? I'll meet you back in my special class session in the evening. Thank you very much. Have a nice time.